All right, so on this one, we are going to we're going to prove that the two triangles are congruent. And that's going to be the basis of proving every property of parallelograms. Now, what are the 5 properties of parallelograms again? The first one is definition, right? What's the definition? Both pairs of opposite sides are parallel. Now, what's the second? Property 2. Both pairs of opposite sides are congruent. And then property 3. Both pairs of opposite angles are congruent. Congruent. And then consecutive angles are supplementary. And then diagonals, which is drawn through the figure, diagonals are, bisect each other. Yep. So let's go ahead and on your page, on the bottom left, let that be point A, and we're going to travel right around the parallelogram just like this, A, B, C, D. Okay? So a quadrilateral is a parallelogram if and only if it has both pairs of opposite sides parallel. So what we're going to try to do is prove that two triangles are congruent just based on that information. Well, do y'all see two triangles? No. All right, so what do we need to do then? Draw a line, right? This is called an auxiliary line, a line that kind of helps us prove something. All right, so we draw that line, and then we say, okay, now I have two triangles, and I have two parallel sides, and I know that parallel tells me something about angles. All right, so we're going to come up here to this angle at the top left. That's angle ABD. What is ABD congruent to? You got to name it correctly, don't you? CDB. CDB. And we say that's by alternate interior angles theorem, right? So if we just say alternate interior angles, that's enough for me. All right? So then what we're going to do is we're going to use these parallel lines up here. We could make a Z out of that, so I know that that is something I could use as well. So this top angle, can somebody offer a suggestion on how to name that one? All right, Crystal, what do you think? Angle? Start here, go there, then down. How would you name that angle? Yeah, that's it. CBD. Angle CBD is congruent to angle. And then we're going to use this one down here at the bottom. So 3 letters for that one. ADB. Angle ADB. And that is also by alternate interior angles, right? And then we can mark the shared side congruent. We can say that BD is congruent to BD by the reflexive property of congruence. If you just write reflexive, that's good enough for me. And now that we have those 3 marks, why are the two triangles congruent? Well, hold on a second. So in order to tell whether two triangles are congruent, you have to focus in on one triangle, and then you're going to go in there with letters A and S. All right? Lost my pen. Okay, so letter A for angle, S for side, and another A for angle. So what triangle congruence theorem is that? ASA. So the triangle ABD is congruent to triangle CDB by the angle side angle congruence postulator theorem. Okay, so now what? Well, we proved that the triangles were congruent, right? Now that we've proven the triangles are congruent, no matter what, if we have a parallelogram, then we can say everything else is congruent, right? Okay, this is the first part that I wanted to do. Let's call this theorem number 1, because we're going to refer back to this one. Okay? So as you flip over, this was supposed to be a graphic where you can fold, but I copied it wrong, so you just have to flip over and look at the top left. It says property 1. Both pairs of opposite sides are congruent. So basically, I want you guys to prove this. Prove this. Okay? So if we go about proving this, the first thing that they'll say is that ABCD is a parallelogram. That'll be,
Teachers, please excuse interruption.